Hello out there, you are welcome to DevTooth Academy, where we are devoted to building academic excellence in students for their STEM subjects. Now, this has been part of a series for examination preparation for further maths WASSCE examination. And now, this type of videos, they are also very relevant not only to WASSCE, it's also relevant to NECO, to GCE, to GCSE, and even for JAMB. Why? Because most of the questions in JAMB are actually further maths questions. And for you to enjoy subsequent videos from DevTooth Academy, what I will advocate for is that you click on the subscribe icon, click on the notification icon so that you get notified about all our videos once we upload them. Share the videos, tell your friends, and then we can learn together. So here we have this question that we are given 3 points that a circle was drawn through center, and we are to find the coordinates of the center of the circle. We are to evaluate the radius of the circle, and ultimately to write out the equation of the circle. Now, if you consider our Cartesian plane and draw a circle on it, we can take the coordinates of the center of the circle on the x-axis and on the y-axis as shown in the diagram. On the y-axis and x-axis, on the x we can call it A, and on the y-axis we can call it B. Now, the circle will have a radius r that is drawn from the center of the circle to any point on the circumference. And with this, there is a general format of the equation of a circle that is well accepted. It's called the standard circle equation, and the standard circle equation was derived from this diagram. Without going to the details of derivation, it is given as x working minus a all square plus y minus b all square is equal to the radius square. Now, this is a standard circle equation, but sometimes working with the questions that we are given, we may not have the opportunity to really express our equation in this. So if you go ahead to expand the brackets, what we are going to get from this standard circle equation is s square. Now we have ax in two places, so we have minus 2ax. Then when the negative multiply each other, we have plus a square. And the same thing will be applicable for y. Y square minus 2by plus b square all is equal to r square. Now, from the left hand side, if you are to put the x and y variables together, we can find s square plus y square minus 2ax minus 2by, then plus a square plus b square. Now, if we take the radius to the left hand side, we have minus r square all is equal to 0. Now, if you're observant, already we are generating another form of the equation. So if we take the constant a square, b square, and r square and denote as z, and instead of using minus 2a and minus 2b, if we revert that, we can find another format of the circle equation, which many times we also find useful, and that is given as s square plus y square plus 2fx plus 2gy. Now, instead of all this a square, b square minus z, we have plus z is equal to 0. This is noted as the general form of the circle equation. Now, having this understanding, we'll be able to go ahead with our questions and try and see what format will be best, will be most suitable for us, and we can answer our question from WASSCE Further Mathematics 2018 theory paper. So now, in this question, we are given that there are 3 points that the circle was drawn through, but if we note the general form of the circle equation, that general form that we have been given, that we just highlighted not too long ago, we can say s square plus y square plus 2fx plus 2gy plus z is equal to 0. Now, for this that we are given, we can take each of those points and substitute the value of x and y into this general equation of the circle, and that will give us some set of equations that we can try and solve. So if you are to take, in the first case, for 3, 2, x is 3, y is 2. If you substitute in this equation, we are going to be having 3 square plus 2 square plus 2f of x, and x is now 3 and f is there, plus 2. Now y is 2 multiplied by g plus z is equal to 0. And if you evaluate this, that will give us 9 plus 4 plus 6f plus 4g, which is 2 times 2, plus z is equal to 0. Now, we can have this as 6f plus 4g plus z. When 9 and 4 move to the other side, they become minus 13. And this we can call equation 1. Now, moving on from there, for the point minus 1 and minus 2, for the point minus 1 and minus 2, if we substitute this value into our general equation also, and we use minus 1 for x and minus 2 for y, what we are going to get eventually, if we substitute just like that, we are going to have 1 plus 4, 2 times minus 1 is minus 2, then 2 times minus 2 is minus 4g. That will give us minus 4g plus z is equal to 0. Such that here we can have minus 2f minus 4g plus z is equal to 1 plus 4 is 5. When we move to the right hand side, it becomes minus 5. And for me, I like to work with positive values, so I will rather multiply all through by minus 1. So we have 2f plus 4g minus z is equal to 5. I can call this equation 2. Now that's equation 2. And in the third case, for 5 comma minus 4, for 5 comma minus 4, I can go ahead and that will be 5 square plus minus 4 square plus 2 into 5 multiplied by f plus 2 into minus 4 multiplied by g plus z is equal to 0. And that will yield 25 minus 4 square is 16. 2 times 5 is 10, so I have plus 10f. 2 times minus 8 is minus 4 is minus 8. Then I have plus z is 0. Now, 10f minus 8g plus z, 25 plus 16 will be 41. When we move to the right hand side, will be minus 41. And this I can call equation 3. Now, interestingly, from trying to evaluate question on the circle, we are now being led to a simultaneous equation in 3 variables. And having a simultaneous equation in 3 variables, how do we go about to solve that? That's what we are going to be embarking upon next. And now, after I succeed in evaluating that, I will check with the calculator to check that I am on track and I'm not missing my questions. So we want to find the variables f, g, and z from this simultaneous equation in 3 variables. As you can see, quite a lot of things are there for us to learn. Like here, we can also learn about solving simultaneous equation in 3 variables. And that's why our advocacy here is always that we can easily study together, we can learn together. And that's why we advocate that go ahead to subscribe to the channel, click on the notification icon, share the videos, like them, leave your comments in the section below, and let us learn together how best we can prepare you for your academic excellence. That's what Deep Tooth Academy is all about, and it will be a plus for you to actually be part of this journey together. So here we have our 3 equations, and when we are solving for simultaneous equation in 3 variables, there are quite a number of ways. What I want to do is I want to eliminate one of the variables. So if I had equation 1 and 2, because I want to eliminate z, I'm going to have 6f plus 2f is 8f, 4g and 4g is 8g. The z plus z minus z will be 0, then minus 13 plus 5 will be minus 8. Now, of course, 8 is common all through. If I divide through by 8, I'm going to have here, I'm going to have f plus g is equal to minus 1. This I can call my equation 4. Let me call that equation 4. Then again, if I look at equations 2 and 3, I can also eliminate z again if I had both equations. So equations 2 and 3 being added together, I have 2f and 10f, and if I add them together, that will be 12f, then plus 4g and minus 8g, that will be minus 4g. The z will cancel out, then 5 plus minus 41 will be minus 36. Again, looking at this, I can divide all through by 4 to have 3f minus g is equals to minus 9. This I can call my equation 5. Now, looking at equations 4 and 5, we can see that if we also add them, g will be eliminated out such that I can have f and easily solve for my f. The g's are plus g and minus g. If I had the 2, that will eliminate the g so that I can solve for f. So equation 4 plus equation 5 will yield f plus 3f will be 4f, then g will cancel out, then minus 1 plus minus 9 will be minus 10, such that my f is minus 10 over 4, and dividing by 2, I have minus 5 over 2. So I have the value of f, that is solved, f is resolved. Now, in one of the previous equations, either equation 4 or 5, I can substitute the value of f so that I can have g. So using equation 4, f plus g is equal to minus 1, and f is minus 5 over 2, meaning that g will be minus 1 minus f. That's minus 1 minus 5 over 2. The negative we multiply each other to give minus 1 plus 5 over 2. And if I find the LCM, that will be minus 2 plus 5, such that g is 3 over 2. Good. So I've obtained g to be 3 over 2. I've obtained f to be minus 5 over 2. I can use any of equations 1, 2, or 3 and substitute for the values of f and g to get the value of z. So if I'm using equation 2, now 2f plus 4g minus z is equal to 5. Meaning that if I substitute my values, I will have 2 into minus 5 over 2 plus 4 into 3 over 2 minus z, which I'm looking for, is equal to 5. So now I can cancel out the 2 to have minus 5. 2 times 3 is 6, plus 6 minus z is equal to 5. And if I move minus 5 and plus 6 will be 1, so minus z will be 5 plus 5 minus 6, which is 10 minus 6 is 4, and that means that my z, therefore z, is minus 4. So with these three equations, I've used elimination method to find the values of my three variables. I want to ensure that I got my values right. So I will use my Casio FX Calculator to also confirm, to note that all these that I've gotten, they're actually the correct values as expected of me. I got f to be minus 5 over 2, g to be 3 over 2, and then z to be minus 4. So I'll bring in my calculator, slot in these three equations, and check if my solution to these simultaneous questions is actually correct. So here, if I go to mode, I want to work on equation, that is 5. And then the format of my equation, if you look at it, is corresponding to 2. That's 3 variables, x, y, and z. So here, it's being put in a matrix format. The instead of having x, y, and z, I'm using f, g, and z now. So 6f, 4g, and 1z, then d is minus 13. Second equation, I have 2f, 4g, I have 4, then minus z, I have minus 1, and then is equal to 5. Then in the third equation, I have 10f, 10, I have minus 8g, minus 8, then z, that's just 1, then is equal to minus 41. Alright. Now if I press equal to, now my x, which is the variable the calculator is using, is minus 5 over 2, y is 3 over 2, and z is minus 4. So I'm actually good to go with the values I obtained. I can move ahead to try and solve my questions as asked for the circle. So now going back to the equation that I started with. So if I'm to recall the general format of the equation I'm using, x squared plus y squared plus 2fx plus 2gy plus z is equal to 0. Now, I've gotten the values of f, g, and z. If you recollect, our f, we have f to be minus 5 over 2, g is 3 over 2, and z was obtained as minus 4. Okay, so if I'm to plug in these values into this general format of the equation of the circle, let me go ahead and do that. So I have x squared plus y squared plus 2. My f is minus 5 over 2 multiplied by x plus 2. My g is 3 over 2 of y plus z is minus 4, that's equal to 0. Now, because of the standard form that we are actually also looking for, we can notice that we can actually go ahead to do the operation of completing the square on this particular expression. Now, again, our question is leading us to completing the square, and you don't need to be frustrated, you don't need to be agitated at all. We can actually take this expression and use completing the square to bring out some very cogent equations, so that we have x squared plus 2 into minus 5 over 2 x plus y squared plus 2 into 3 over 2y. Now we have plus minus 4 is equal to 0. Now I'm deliberate not to cut out like this because I want to try and complete my square. Now, generally, when we are having a factor, let's try and explain that. Generally, when we're having, let's say, x plus minus 5 over 2, and we are squaring all this. Now, let's try and expand this. This will be x plus minus 5 over 2 multiplied by x plus minus 5 over 2. Now, if you open this bracket, that will be x multiplied by x squared, and x plus multiplied by minus 5 over 2 in two places. That will be plus 2 into minus 5 over 2x. Okay. Then minus 5 over 2 multiplied by minus 5 over 2 will be minus 5 over 2 all square. Now, we need to look at this expression critically, and we'll evaluate that. What we are having in our equation that we are coming from is x squared plus 2 into minus 5 over 2x. And that will be equal to, now, the left hand side, if you take minus 5 over 2 squared to the left hand side, we have x plus minus 5 over 2, everything all square, minus 5 over 2 square. Now, I took the time to explain this because I'm going to substitute these values into this equation, and we can do the same thing for y, such that from there, what we are going to be having is, we'll have, instead of writing x squared plus 2 into bracket minus 5 over 2x, we are going to write this expression on the right hand side. So, if you are to do that, what we have is x plus minus 5 over 2, everything all square, minus 5 over 2 squared. The same thing for y will give us y plus 3 over 2 all squared minus 3 over 2 squared plus minus 4. So, this we can go ahead to say is x minus 5 over 2 all square plus y plus 3 over 2 all square. Now, minus 5 over 2 all square will be 25 over 4. Then minus 3 over 2 all square will be 9 over 4. Then we have minus 4, all is equal to 0. And I'm doing this because I want to revert back to the standard form of the circle equation so that we can get the coordinates and the radius of the circle. So having this, we can clear our board and write out our equation as desired. So here, that means we have x minus 5 over 2 all constant plus y plus 3 over 2 all square is equal to, when we move all the other constants to the right hand side, 25 over 4 plus 9 over 4 plus, now 4 can be taken as 4 over 1. And so we find the LCM for, we have 25 plus 9 plus 1 in 4 in 4, 4 times 4 is 16. So that will be 25, 9 and 16. That will be 4 and 16. That will be 50 over 4. So that will, 2 will go and we have 25 over 2. Such that our expression for the equation of the circle will be x minus 5 over 2 all square plus y plus 3 over 2 all square, and that is equal to that's 25 over 2. But I want to postulate something. If I say 4 and I have square root of 4 all raised to power 2, that will be 2 raised to power 2, which is equal to 4. So finding the square root and squaring is actually annulling each other. That means I can say this is square root of 25 over 2 all square. It's as if I'm just writing 25 over 2 alone. Now, for this new equation that we have obtained, if we compare to the standard form of the equation of a circle, if you are to compare this to x minus a squared plus y minus b squared is equal to r squared, we can see that our coordinates is easily obtained, our radius is obtained, then the coordinate of the center of the circle will be a comma b, and comparing the two, we can see that minus a is 5 over 2, and our b will be minus 3 over 2. Now, the thing to note is that we may make the mistake to just say 3 over 2. No, it is minus 3 over 2. And from there, the radius is the square root of 25 over 2. And just like that, we have gotten the center of our circle, the coordinates, and the radius of the circle. Now, the equation of the circle, we could as well leave it as what we obtained before, x minus 5 over 2 all square plus y plus 3 over 2 all square is equal to the square root of 25 over 2 all square, or just ordinarily 25 over 2. Either of the two is the same. But interestingly, we can go ahead to expand the bracket, then evaluate, simplify the equation, or from the general format of circle equation that we use, x squared plus y squared plus 2fx plus 2gy plus z is equal to 0, we can also substitute the values of f, g, and z. F is minus 5 over 2, G is 3 over 2, and Z is minus 4. We can substitute these values back so that we have x squared plus y squared plus 2f is minus 5 over 2 plus 2, G is 3 over 2 multiplied by y, Z is minus 4 equals to 0. And here, if we just cut out the 2's, our equation will come out as x squared plus y squared minus 5x plus 3y minus 4 is equal to 0. And with that, we've been able to evaluate the equation of the circle, the coordinate of the center of the circle, and the radius of the circle. It's quite a lengthy video, but I took time to just explain how do we solve for each of these using our simultaneous equation in 3 variables, trying to complete the square so that we can have a grasp of all these tools to try and evaluate our question whenever we have them. It's DevTools Academy again. Don't forget to like the video, share it, subscribe to the channel, and until next time, God bless you.